All right. So how does this look behind me, though? You guys can see it all?
Yeah.
Okay. So number one, it asks you to look at this polygon, this shape, and tell me what's the name of it and how many vertices there are. So first we need to figure out how many sides, because the number of sides changes the name. So there were 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 sides. If there's 10 sides, who knows the name that goes in front of that?
Star.
No. Anybody?
A pentagon.
Not a pentagon.
I mean,
Hexagon is 6. Septagon is 7.
if it's
Octagon is 8.
a nonagon.
Nonagon is 9. Any ideas what 10 is?
Decagon.
What?
Decagon.
Close. A decagon. Like a decade is 10 years. A decagon is 10 sides. So it's decagon. Kind of looks like a demogorgon.
Decagon.
Deca, deca, sin, yeah. And then the number of vertices is how many? 6, 7, 8, 9, 10. Oh my gosh, there's 10. Whoa, what a concept.
I got it right.
Yeah. 10 sides means 10 vertices as well. So a decagon is a 10-sided shape. Doesn't matter if it's equal sides, it's just a 10-sided shape. Number 2, we are subtracting decimals. When you subtract decimals, what do you have to do first? Line them up. So our decimals line up.
That one I did in my head.
2.46. This one's a kind of easy one. So what is 8 minus 6?
2.
2. 9 minus 4?
5.
What do I do with my decimal?
Your decimal down.
Drop it straight down. What's 2 minus 2? 0. So we have 52 hundredths as our answer.
That's what I got.
Good.
I didn't get the first one.
Number 3, we're finding the volume of a rectangular prism. How do you find the volume? What do you do? Multiply.
You have to multiply length.
Good, yes. Length times width times height. What is the length of this? 6 times the width times the height. 4. 6 times 3 times 4. What's 6 times 3?
18.
18. So we got to do 18 times 4.
72.
Yeah, 72. 72 is correct. Volume is 72. What? What's my unit? Centimeters. Not squared. Squared is area. What's volume? Remember, if it's 3 sides, what is it? To the third
Power.
To the third power. Or cubed, right? Centimeters to the third power or centimeters cubed. Either one works. Number 4, what's the difference between the number of 12-year-olds and the number of 16-year-olds? They also said that each X represents how many kids? 7 kids. Okay, so we need to look at 12-year-olds, 16-year-olds. So how many 12-year-olds are there?
There's 6. Wait, no, 5. 6.
Well, we need to take the number of X's, multiply it by 7 kids. So we have 1, 2, 3, 4, 5, 6 X's, but each one is 7 kids. So that's 40. Whoa, what was I trying to write? I don't even know. So this is 42 kids that are 12 years old that were at this camp. Were they at a camp?
No, it was a band.
A band thing? Okay.
A banjo.
So 42 kids are 12 years old. How many are 16?
2.
Well, there's 2 X's, but each X is 7. So each one, there's 14 16-year-olds. And then we need to find the difference. How do I find the difference? Subtract 42 minus 14. What is it? 42, 14. 3. 28. So 28 more kids are 12 years old than 16. Yes. That's true. You could have been like, okay, well, 2 of those go away, so 2 of those go away. So what's 4 times 7? 28. That is a good way to do it. You could do it that way as well. All right, our last one, number 5, order of operations is PEMDAS. Let's start with parentheses. Do we have parentheses? Yes. We have 2 things happening inside the parentheses, so we still have to do order of operations inside the parentheses too. So we are adding and subtracting. What do I do first? add first. So we have 8 minus 9 times, what's 4 times, or 4 plus 19? 4 plus 19.
Oh, that's
23, thank you. Minus 30. So now we need to do the rest of our parentheses. 23 minus 30. This goes negative. We haven't talked about this. Yeah, I heard it is negative 7. So you would take the bigger number, 30, subtract 23 and get 7. Take the sign in front, so it's a negative 7. So this is 8 minus 9 times negative 7. We have not done this before.
I don't know how to do it.
We've kind of talked about it a little bit, but we need to take
9 times negative 7.
Let me finish talking. Let me finish talking. We need to take the negative 9 right here, multiply it times negative 7. So we have 8 and then negative 9 times negative 7. We have not talked about multiplying positives and negatives yet. We've kind of said a few things next year, not in 6th grade really. But when you are multiplying two negatives together, it just makes it a positive number. So you multiply like normal. What's 9 times 7? 63. These are both negatives, so it just makes it a positive 63. So this is 8 plus 63. Plus. Because it's negative 9 times negative 7, it becomes a positive, which is adding.
What I did first was to do the 8 minus 9, and then I multiplied.
Nope.
I got negative 1.
Yeah, with order of operations, we still have to do this multiplication before we can do that last bit of subtraction.
Yeah, it would make it easier if they made a dot there, like counting as kind of parentheses. So
Yeah, I know what you mean. What is 8 plus 63?
71.
71.
I got negative 71 because I got naked. I multiplied it into the division.
Yeah. What?
I mean negative.
Oh, okay.
I got
Let's talk just really quick, because I don't know if this will be on your AZ merit or not, so let's just do this really quick. If I take 2 times 5, what do I get? 10. What if I take negative 2 times positive 5? That's a negative 10. Because you're taking a negative times a positive, it just makes it a negative. I don't know why, that's the rule. It just becomes negative, there's no rule, that's just the rule. Sorry. This is multiplication. Yes, only in addition. Okay. And then what if I take negative 2 times negative 5? Negative times a negative. It's a positive. So when the signs are the same, so this is a positive and a positive, it stays positive. If it's a negative and a negative, it turns positive. If they're different and you have a negative and a positive, it's negative. That's the rules on that. You'll go more in depth when you get to 7th grade about that, but I don't know if it'll be on the AZ Merit or not. So there's a little bit of information for you right there. Okay? All right, let's I think your assignment posted. We're gonna do one together, and then I'm gonna give you guys the time to do the rest of them on your own because it's stuff that we've been doing for about 2 weeks. So let's go ahead and head over to Google Classroom.
Oh, this one's easy.
All right, so no, we're doing one problem, not one slide. So scroll down to math. It's called Tables and Graphs Practice. Oh, well, I clicked on the wrong thing. Hold up. There we go. Tables and Graphs Practice. Go ahead and open up those Google Slides, please. I'll give you guys a second to get that opened up. I signed it in on that. Don't sign it in.
I accidentally did.
You need it returned to you? Yeah.
Please don't submit.
I guess. I'm just gonna put back where you need it. I don't know what I was doing. All righty. Let me check on you guys really quick.
Make sure you're listening.
Okay, so have this pulled up on your screen. We're going to get zoomed into number 1 so that we can see number 1 pretty well. The zoom on this isn't going to be great. So we're going to look at number 1 and fill out the table, and then we'll use these 4 dots to put the ordered pairs on our graph. So they give us the equation. We use the equation to fill out the table, and then we have to plot the points. That's what you're doing 6 times. We're going to do it 1 time together for number 1. You guys will be responsible for doing the rest of the 2 slides. Make sense? Okay. So I'm going to kind of work it out a little bit behind. Oh, hang on. Let me erase all this first. So I'm going to work it out a little bit behind me. So we have y equals 2x plus 2. Before we start, what operation is happening between the 2 and the x? We're multiplying 2 times x. So keep that in mind. So we have our x's and our y's, and they give us 1, 2, 3, 4. Easy. 1, 2, 3, 4. So our x value is 1. We will plug in 1 and do order of operations. We'll plug in 2, 3, and 4. So this would be 2 multiplied by 1 plus 2. What is 2 times 1? 2 plus 2 is 4. So let me do this a little bit better. Y. This is our work, just to show it, right? So in that first part for y, or for number 1, we need to put what as our first answer here across from the 1? 4, because when you plug in a 1, you get 4 out of your input machine. Remember that function machine we talked about? Yeah. This is exactly what we're doing. We're taking our x value, plugging it into our function machine, and spitting it back out to get our y value, right? So let's plug in a 2. This would be 2 multiplied by, what's our x value here? What's my x value?
X value is 2.
2, and then we'll add 2. So what is 2 times 2?
4.
4 plus 2 is 6. Our x value for that one is 6. Sorry, our y value, my bad. So we will put a 6 in box number 2. Okay, what about the next one? What will I write in my area here for the work? 2 times 3, we're taking the number 2, multiplying it by 3 because that's our x value. Then what? Then plus 2. So what is 2 times 3? 6 plus 2 is 8. So what do I put in the box? 8. Do you see a pattern here too?
Yeah, it's going by 2.
It is going by 2s. Let's work out that last one though. What will I write?
You will write 2 times 4.
2 times 4 plus 2. What is 2 times 4? 8 plus 2 is 10. So we get 10 in that last box. Just sneeze. 10. Okay. There's our table filled out. Do you have any questions about how we got these numbers?
No, I guess
Makes sense here. All right. Now, I'm going to kind of get rid of some of this a little bit. We did all that work. We got our y's.
So now you can put your answer.
What was it?
4,
4, 6, 8, 10.
6, 8, 10.
Okay. How do I graph these now? How do I graph something like this?
You have to graph, so you have to go on X, which is the bottom, and then you go to 1, and up 4, and 2.
Good. So we have to use our x's and our y's. So remember, an ordered pair goes x and then y. We have an x value here. That's the terrible y. We have an x value of 1, a y value of 4. So we have plot our first point at 1, 4. What about this one? What would it be?
Oh, that one would be 2, 6.
2, 6. Over 2, up 6. What about the next one? 3, 8. Over 3, up 8. And our last one?
Last one would be over 4 up 10.
Over 4, up 10. So these are the ordered pairs that we're going to graph using those dots that are on the slide. So let's move our first one here. 1, 4. We got to move down. Yep, got to be able to see it all though. There we go. So over 1, up 4 is there. There's our first one. So you just put the dot at the ordered pair. Over 1, up 4. Yoshi, do this with us.
Okay.
What about the next one?
So over 2 up 6.
Over 2, up 6. Oops, I messed up the dot. There we go. Over 2, up 6 is about there. As best as you can get it, as close as you can get it. If you're doing it on paper, draw a dot where it's supposed to go. The next one is over 3, up 8. So we would go to the right 3, up 8. That one wasn't very close, but that's all right. Our last one goes where? Where's the last one go?
Oh, up 4 up 10.
Yeah, to the right 4, up 10. That wasn't very even, but in 7th grade, you guys will start connecting those into a line, and
Will there be shapes you can connect them into?
eventually, yeah,
In like high school?
probably, yeah.
So is there a lot of bugs or
No, this is
that
called a
one-
linear equation graph. Yeah, you'll learn it in 7th grade.
Okay.
It's not a bar graph because there's no bars. Right now, you would know it as a line plot because we could connect the line if we wanted to. But that's what you're doing for the rest of these. Filling out the chart, plotting the ordered pairs. Do you guys have any questions on what needs to get done on this slide? So there are 5 more for you to do, the 2 on this slide and then the 3 on the next slide. They're all kind of like 2 steps, right? Multiply and then add, or multiply and subtract. Some of them are just 1 step where you just need to add, which is nice and easy. So that's what you guys are working on. I'm going to stop the recording, but I'll leave this on so you guys can yell if you need help online. Mr. Turner and I will be walking around in here if you need any help. So go ahead and be working on that, please.